Have you ever imagined that a storm on Earth could impact the environment in space? Surprisingly, new research has shown that lightning storms don't just influence our weather, they also play a crucial role in space weather. These storms can dislodge high-energy electrons, colloquially known as killer electrons, from the inner radiation belts surrounding Earth. These high-energy particles pose significant risks to satellites and even astronauts. This video will explore this fascinating discovery, detailing how it happens and why it is crucial for our understanding of space and satellite safety. The inner radiation belt around Earth has long been considered a relatively stable region in space. Scientists assumed it mainly contained lower energy particles, which posed little threat to satellites or human space activity. However, a team of researchers led by Max Finnan from the University of Colorado Boulder has recently found high-energy electrons in this supposedly stable region. This finding challenges our previous understanding of Earth's radiation belts. Using data from NASA's decommissioned SAMPEC satellite, the researchers identified 45 electron surges in the inner belt from 1996 to 2006. These surges were linked to lightning strikes on Earth. What was previously considered an inactive zone for high-energy particles turned out to be more dynamic and hazardous than we had ever imagined. High-energy electrons, known as killer electrons, were found in this inner radiation belt, and they can be damaging to both electronics and satellites, as well as to humans in space. Researchers discovered that the radio waves generated by lightning travel into space, knocking electrons loose from the radiation belt. This phenomenon, termed electron rain, is something that science had never fully measured before in the inner belt. When lightning strikes, it doesn't just light up the sky, it also sends powerful radio waves deep into space. These waves collide with electrons trapped in the Earth's inner radiation belt, shaking them loose in a process called lightning-induced electron precipitation. To visualize this, think of shaking an umbrella to dislodge water droplets. This effect is one of the primary ways these high-energy killer electrons are knocked free from the inner radiation belt, posing a threat to the satellites orbiting above us. But the process doesn't stop there. After a lightning strike, the resulting radio waves trigger what can be described as a cosmic pinball effect. Electrons start bouncing between Earth's northern and southern hemispheres at incredible speeds, a process that can happen within 0.2 seconds, faster than the blink of an eye. Each time the electrons bounce, some of them escape the radiation belt and fall into Earth's atmosphere. This discovery highlights just how unpredictable space weather can be. The notion that a lightning storm in North America could affect a satellite orbiting thousands of miles above Earth is both awe-inspiring and a little terrifying. It underscores the fact that Earth's atmosphere and space are intricately connected. Everyday weather events can influence the space environment in unexpected ways. The implications of these findings are profound. Killer electrons are far more dangerous than their lower-energy counterparts because they can penetrate even the most advanced shielding used on satellites, leading to severe electronic malfunctions in space. Electronics are highly vulnerable in the harsh conditions of space, and when these high-energy particles hit sensitive components, they can cause short circuits or electrical discharges, which could disable critical systems. This threat extends beyond electronics to human space missions. Astronauts aboard the International Space Station, ISS, or those involved in future deep space missions face potential health risks from these particles. When high-energy electrons penetrate the spacecraft's shielding, they could expose astronauts to harmful radiation, increasing the likelihood of radiation sickness or long-term health issues, including cancer. The study of the Van Allen radiation belts through NASA's Van Allen probes, which have been operational since 2012, has revealed how solar activity significantly energizes electrons in the outer belt during periods of intense solar storms. The Sun releases vast amounts of charged particles that get trapped in Earth's magnetic field, filling the outer radiation belt with high-energy electrons. These killer electrons, energized by solar activity, behave similarly to those triggered by lightning strikes in the inner belt. This revelation is critical as it shows that the dangers posed by these electrons are not isolated to solar events, terrestrial weather events, such as lightning, can now be added to the list of space weather influencers. The findings from the Van Allen probes highlight how solar activity and lightning together represent a twofold threat to both satellites and astronauts. This stresses the need for protective measures and improved forecasting models to predict high-energy electron events more accurately. Another fascinating element is the role of Whistler waves in influencing the behavior of killer electrons in the radiation belts. Whistler waves are low-frequency electromagnetic waves generated by lightning, and they can scatter high-energy electrons. NASA's Themis mission has demonstrated that these waves can dislodge electrons from their usual orbits, sending them spiraling down toward Earth's atmosphere. In fact, these Whistler waves act like invisible conductors of space weather, determining where and when high-energy electron precipitation will occur. This process is similar to how solar winds influence electron behavior during solar storms, reinforcing the idea that space weather is influenced both from above, like solar activity, and from below, through terrestrial events such as lightning. This new knowledge about Whistler waves highlights the complexity of space weather and shows that we must consider Earth's weather and solar activity when assessing risks to space operations. As our reliance on satellites and space missions continues to grow, predicting and mitigating these space weather events will be crucial for safeguarding both technology and human life in space. In conclusion, the interconnectedness of Earth's weather and space weather opens new avenues for research and understanding. The role of lightning in triggering high-energy electrons in the inner radiation belt has far-reaching implications, not only for satellite operations but also for the safety of astronauts in space. As we delve deeper into these phenomena, the necessity for improved monitoring and predictive capabilities becomes increasingly evident. Understanding how everyday terrestrial events like thunderstorms can influence the environment in space emphasizes the delicate balance within our planetary systems. Thank you for watching, and stay tuned for more exciting discoveries about our planet and beyond. As we continue to unravel the mysteries of our universe, it is essential to remain aware of the ways in which our home planet impacts the vast expanse of space. The journey of discovery is ongoing, and each revelation leads us closer to a comprehensive understanding of the complex interactions between Earth and the cosmos. With further research and innovation, we can develop better strategies to mitigate the risks posed by these unexpected influences, ensuring a safer future for space exploration.